Hi everyone. Today we're going to be doing some applications of area and working with some compound or composite shapes. Before we do that, let's warm up. Can you please pause the video, write 3 area formulas that we learned yesterday, and find the area of these 2 shapes, and then come back and check your work. Alright, let's see how you did. So the area of the rectangle is, remember, the length times the width. The area of a parallelogram is very similar, except we call it base times height, where the height is that vertical distance between the 2 parallel sides. And the area of a rectangle is the area of a triangle is the parallelogram, but divided in half, like that. So I wrote my formula, I filled in my numbers, and I calculated. And I remembered my label, kilometers squared. I wrote my formula, filled in my numbers, and calculated. Many times with shapes, they're not just a single shape. They're a composite, or they're many shapes put together. So when you have an odd shape, try to find if you can see smaller shapes that you know how to find the area of that might make up the larger shape. So I want you to again pause and see if you can split this shape into smaller shapes. There's more than one way to do this. Here are the 2 ways that I saw right off the bat. I drew a line splitting this into 2 rectangles on the top with a rectangle on the bottom. And then this way I split it so there's 2 tall rectangles with a rectangle in the middle. And so to find the total area, you'd find the area of all of the pieces. So here, this is 2 by 4, so that's 8. And this would be 2 by 4 as well, because if this is 4, this is 4, so this also would be 8. And then, common mistake is taking this 9 and multiplying it by the 7. But remember, we cut off 4 of this, so this part right here must only be 5. So 5 times 7 is 35. So 35 plus 16 would give me an area of 51 meters squared. What if we did it this way? 2 times 9 is 18. We have another 18 over here. But now what about this? Here, right here, this whole thing is 7. But we have this part which is 2 and this part which is 2. So this length right here must be 3 to make up the total 7. 2 plus 3 plus 2 is 7. And then here we found it over on this first one. But again, how we did that was 4 of this was used. So of this 9, only 5 is remaining. So 5 times 3 is 15. So we have 18 plus 18 plus 15. So 16 plus 5 is 21. And this would make 51 as well. So you see, there is more than one way to cut up the shapes. We could have also put a big rectangle all the way around. So the area of this whole thing is 63, and then taken out this part right here that wasn't used. So 4 times 3, we found the 3 over here. 4 times 3 is 12, so 63 minus 12 also gives us 51 meters squared. So the first 2 ways, we split it into smaller shapes and added them up. And the last way, we made one big shape and then took away the piece that wasn't part of it. All right, I want you to try to do this one on your own. Bottom line is, here's a wall. The windows and the doors are not going to be painted, so how could you figure out the area of the wall that will be painted? And then, given that area, if a quart of extra thick gooey sparkle paint covers 30 feet squared, how many quarts are you going to need? Pause, do your work, and then come back to check your work. Alright, hopefully you actually paused and did the work. What I did was first find the area of each part that needs to be cut out. So 2 feet by 2 feet would be 4, 2 feet by 2 feet would be 4 square feet. And then I have a 6 foot by 3 foot area, so 6 times 3 is 18. And again, these are rectangles, so I'm just using the length times the width to get 18. Then I found the whole wall. It was 8 feet by 12 feet, so if I did length times width, that would give me 96 feet squared. Then I had to subtract the doors and the windows and the door to get 70 feet squared. So that's the area of the wall that will be painted. Now, if each court covers 30 feet, 1 court would cover 30 feet, 2 courts would cover another 30 feet, so now we're up to 60. So we really need 3 courts because 2 courts would not be enough. 3 courts would have us up to 90. So we'd use about 2 1/3 quarts, but we'd have to purchase 3 quarts. Let's try another one like that, but this time there's no story involved. It just says to find the shaded area, so this part right here. So we have to find the big area and take out the small area. So in all of these I'm going to be doing, and I like to keep it organized, so big, the big area is length times width. And I'm going to subtract from that the small. It is going to be very helpful for me and you if you can show your work like this. Label the different parts that you're finding, so that way someone reading your work, you or me or a classmate, knows what you're thinking. So now I know I'm going to take this area and subtract the smaller area. So when I did the calculations, and again, I don't care if you use a calculator, I found this product, and then I subtracted to get the area that was remaining, 695 centimeters squared. Alright, this one is more like the first couple problems we did, where you're trying to split it into different segments that would help us figure out the total area. So I see here to here is 9, and this is 18, this is 21, and this is 6. And this part down here is 21. So lots of different ways we can do this. We can split it into different rectangles, or we could put a rectangle around the whole thing and then take off the parts that are not part of the shape. But before we do anything, we have to find some missing measurements. So here, if this is 33 and this is 21, that would leave 12 remaining, and these are equal distances, so that would mean each of those are 6 and 6. And this looks like a 1 square to me, so that seems about right. So I'm going to use a method of subtracting the smaller pieces. So I'm going to figure out the total area. So I have my 18 and 9, so this whole thing is 27. And I can check it over here as well because I had a 21 and a 6, which is 27, and a 33. So my big area is length times width, 33 times 27, which is 891 centimeters squared. And I'm going to subtract from it this first small and the second small. So I'm going to subtract from that my 6 times 9, right here, 6 times 9 is 54, and right here, 6 times 6 is 36. So when I take those off, I'm left with a grand total of 801 centimeters squared. So to review what we did, we took and put the big square around and found the area of this whole thing, and then we took off of that or subtracted off the area of this small and the area of this small. Lastly, a word problem. This word problem, in my opinion, is pretty easy, but you have to read carefully. So pause, see if you can figure this out, and then come back. Okay, hopefully you got this. This is a parallelogram, so we're going to use area equals base times height. So 7, and then here's my height. So 7 times 6 is 42 inches squared. That is just for one of them, though. We need to know, what if she knitted 5 of them? What would that total area be? So I just took the area of 1 and multiplied it by 5 to get 210 inches squared for 5. All right, that's it for today's lesson. Let me know if you have questions. We out.